Good evening, everyone. My name is Josiah Masuike. Today, I would like to give you a breakdown of our development and the product that we've built. The name of our product is AI Native Immune System and Governance Platform, AINISG. We've used AI agents to build fleet of agents that could be able to protect our environment. This fleet of agents stem from Universal Codified Hypervisor Units. These are interfaces that could be able to go into various layers. In our security layer, that's where we built all this governance aspect in. When you look at what we have done, we've been able to make it possible for organizations to be able to measure what is trustworthy in the code base, as well as what is secure in the code base. Since AI is a powerful force multiplier, it has been able to accelerate all development and automation, which exposes organizations to increased attack surfaces. Our answer to that is AINISG, AI Native Immune System and Governance Platform. We want to change the detect and response paradigm in cybersecurity to immune system in cybersecurity. What do we mean by that? This simply means that organizations should be able to be on alert 24/7, protecting their environment as opposed to waiting for a breach to happen before they can respond. We build fleet of agents to take care of it. One of the fleet of agents will do it front facing for customers, and another will be our ethical hacker penetration tester called Ghost, and another one will also be immune. They all belong to the same family of Universal Codified Hypervisor Unit. They are capable of inserting themselves where other agents could possibly insert themselves. The difference is that they insert themselves for a specific purpose to defend the environment. Organizations today can build any kind of tool, whether it's a SIM tool, SDR, EDR, they can customize it for themselves. This is turning cybersecurity upside down. No need to buy tools that are not designed for your environments. No more tool sprawling. All of that could be done in one place. I also find Replit to be a powerful infrastructure that organizations can depend on. It makes disaster recovery easy for you. It was able to give those who are resourceful a way to do many things that makes their environment and their application robust with failover, fault tolerance, and very high availability prone. We want to demonstrate this and showcase some of the things that we've built, but we cannot do that without letting you understand the engine behind it. The engine behind it is XMID, which is endpoint cryptographic system for cloud, mobile, and IoT devices. This is the initial technology we started off with. It could not be sold because it's deep tech and high tech, but we have made it possible using our AI security module to transfer that complexity into the platform that you see today. I'll go ahead and show you in a nutshell what we've built, and I can demonstrate this. These are all that we've built, from Ghost Dashboard that reports all incidents and number of attacks, and et cetera, to our fingerprint universal identity verification system, which identify all agents that are in use, and our authentication process, which has a battery of multi-factor authentication. The list goes on. But what you need to understand is simple. Here, you can see our protection system, which is a lockdown security layer. We have everything that you want to cover to be ready for SOC or any other compliance. Okay, so it could be 27,001 readiness evidence, and so on and so forth. Now let's actually go in and see what we built. I'm going to log into an account. This system production environment has been in operation since April 4th. It's completed and we're trying it out. And we see that it's impenetrable and it works perfectly well, because we can tell you the experiences we've learned while building this and the things that we've seen in this space. It's amazing. So we can do what I call a 7-way handshake. I can also show you what's under the hood of that, so you could be rest assured that we know what we are talking about. So this network, you're gonna see what's under the hood. I will go ahead and set the section to an hour. This section, time to leave could be determined by you, so that we want to cut down our footprint online on the caches that are cached and so on and so forth. So caches are encrypted, sorry, not cached. I'm sorry about that. So what you see under the hood here is step 1 of the 7-way handshake. You see everything gets encrypted, okay? And the seal means encryption. Even though seal is also encrypted, so we have ramification, different kind of algorithms that is being used. As you can see, step 7, that is, and that's the license, the person that logged in, which is me, infinite license. I have my security processing credit is like infinity. So that's us logging into the system. Let me make this smaller. While we're in the system, I can show you things that you might not think is possible to be built in one place, but this is it. Here you can see this is my account. This is how I build my confidence and the level of trust that I have by using my driver's license. And you can use other provenance to boost the confidence, your confidence as you interact with other people, so that way they won't, it's like photo verification. This is more on a high level security, high sensitive data organizations. That's who will use this. This is not consumer product. Now, these are the devices, just like you have a ring, you can add all your devices so that when you log into them, it won't be a problem at all. This is Xmeet Playground. Xmeet Playground is where you come in for the first time. This is where we get your fingerprint. If you come into our system, we create fingerprint for everyone. So that way we can use it to identify you, and that's what you use for authorship, and also you use it for ID gating. So here, if we encrypt this, we want to make sure it's sound. So let me go ahead and encrypt it. So here, this is the encryption. I'm showing everything instead of bulleting it so that you can see the entropy in there. It's UTF-8, which is the complexity is high up. The entropy is up there as well. So that's that. And also, we do have a way of working with, those of us that are relying heavily on GPTs and so on and so forth. That I can show you later on. So let's move forward. This is file seal. The file seal can encrypt any size of file that you want. We can encrypt this picture here. Okay. That's about 2.47 MB. The encryption is done. And we can basically we can just take a look at it over here. Okay, so this is the encrypted file here. I'll show you. This is the encrypted file here. Let's find the encrypted file. I don't know where is that. I'm still looking. This is the encrypted file here. Don't worry about the notepad preview. So I'm gonna delete the old shoot. I deleted that one as well. I'm sorry. So we're gonna have to download it again. That's fine. So I deleted that. Okay, this is the encrypted file. I'm gonna go ahead and decrypt it. Click decrypt. Go here. And I go to decrypt. That's that. And I just go to decrypt. You should be able to decrypt it. I'll say unseal, which is decrypt. And it will just unseal it. I'll download it. Once we go in there, if it's successfully unsealed, we should be able to see it. No question asked. That's it right here. Okay, it's popped out. We did it, decrypted it. That's it right there. It's very clear, just like the other one, just to make Make sure nothing is off. Okay, that's the data. It's back up, and we've been able to do it. It's successful. Moving on. Now, this is a secure vault. Secure vault basically is where you hide all the information that you want to hide, just like let's say blockchain seeds and all of that. You hide it here, like you open up add entry, so you can add whatever entry you have. These are entries that I added, especially I use it to hide my GitHub tokens so that AI cannot go and steal them and play with them. It's very good at finding stuff. So this is my stuff. This is how I do it. Of course, it's my account. Now, another thing with the Secure Vault is in Secure Vault, we use it to for production release status, which is a part of our development. So there's governance, heavy governance, because you gotta have um, evidence readiness for like SOC 2 evidence readiness and all that kind of stuff. You gotta have it. Whatever compliance, GDPR, all of that, you have to have that. So when the auditors come in, it will be easy for you. So we document all our deployments here in production. You can see that's read only. That gives you an idea if you are working with our tool and so on and so forth. That's the governance part. Okay. So we encourage people to keep the secret and not play around thinking that it's secure when you put it in the secret of third-party infrastructure. Now, there's also secure meets API credential. This is how you get API from us. In this case, I don't have one, so it should be, you should fail to fetch it in principle. Now, secure meet is basically a keyless system. It's keyless PQC. And here I can clearly demonstrate to you some of the things that we've done with encryption. Here, that's only me there. Let me see if there's any other person there. Okay, there is someone else there. So let's see if we can send. Okay, it's only me there. It's not going to help us any good. So let's go back. Let me find one that has someone else in the space. Okay, this one has someone else in the space. So let's try this one. This one might work. All right, this is great. This is my COO. So I'll just go ahead and send a message. Hello. I did spell it right. So right there, everyone in the channel can read that once they click on it. But I can also go ahead and make it specific. If I type hello and I send it specifically to someone in the group, only that person will read it. So we have ID gating and authorship here. So if I send it to, let's say I send it to Dr. Bailey here, I click send. When I try to read it myself, I'm not going to be able to read it because it say that it's sealed to that particular person. You can encrypt WebRTC using the same technology that we've developed over the years, and there's so much you can do with that. We want to make a long story short, we want to move far to the right here so we can demonstrate most of the agents. These are agent fleets. This is support. This is ghost. This is immune. I can query them. They are conversant with MCP, modern context protocol, but I pipe them with encryption algorithms, so that way they are very unique in their action. I can ask any of the agent anything. Okay, how is the attack volume today? Just a question. I can seal the question, meaning it's encrypted to go to it. As you can see, that's it over there. I can dispatch it. It will get it. It will now respond back to me. If all goes well, you should be able to read its response, and so on and so forth. So that's that. That's its response right there. As of the latest scan, the attack volume on lockdown infrastructure is within expected parameters. Here's the summary. Just give me the summary of everything. if there's an intruder or anyone out there picking in, they're not gonna be able to see anything because you saw me encrypt that stuff and it came back the same way. So that's the beauty of our work. We are able to prove that you no longer have to move keys, store keys, reuse keys, or manage keys to do perform this kind of encryption, which makes it very nimble, and we are very responsive to AI that that is powerful in automation, making sophisticated approaches of attack very simple. So that's one scenario there. There are so many things that these agents can do. This is also a PDAT. Today, all communication over the wires are is just observability. If packets is moving, nobody can cryptographically prove that they one packet left this wide area network or router to another one. But what we built is proof of device adjacency traversal, which is very interesting. So I can demonstrate one of it. It's very complicated, but I've been able to simplify it. So basically, we have authorship and ID gating. So I can initiate to send information to myself. Once I do that, I can send anything to myself is going to be encrypted. But how do we know that? How do we know that when it hopped over the wires, went over the wires, that it was the same message that passed through in a cryptographic sense? We don't. We rely heavily on the packets moving around or observability. Now, I can try to prove this in a cryptographic sense because of the algorithm that we've utilized or what we've implemented. So bear with me a moment. Sorry. I want to go and get my universal wallet address. So I paste that here. Destination or is myself is gonna come back to myself. Go to the internet and just come back to me again. So this is the chain ID here. This is chain ID. We have to compare the chain ID. But before we do, let's go to complete. We go to complete. We see an unsealed pair. We go back to chain. We're gonna see action required. We're gonna click on complete this claim. So we're gonna copy this because we're gonna check it with what we're gonna see going the other way. So verify seal. This is complete claim chain. Okay, verify seal. So I'm gonna verify it. Boom, it's completed. This is confirmed. So when I go back to chain again, you see it right here completed. If you check this right here, it's the same thing. I get it to be bigger. This right here is the same thing as the chain ID that we had. What does this mean? It simply means that if you have a function FFS, which is encryption, and there's a content in it, a payload, and it was sent out, and whoever received it have to reverse the process, and the time is given. So in that case, I send it to myself. The idea is there's a cryptographic proof, underlying cryptographic proof that's within the function. The function FFS is an example. There's more stuff, complicated stuff behind that happens. So the first message was the second message, but then the message has the same fingerprint. So if they have the same fingerprint, they are the same. So cryptographically, we can prove that it's the same message that moved from point A to point B. It's not just an observability, although the hop is 0 because I sent it back to myself. Okay. So that's the idea there. There's a lot more to it, but we just want to keep it simple. This is very CCPA and GDPR compliant. If you don't want our service, you can check out. So this is basically a change request. All the deployment we did since we started building this, they're all here. None of them are missing. We have rescores, prison score, we have section rescore, and etc., etc. And the beautiful part, the part that I really like, is me being able to get to my remote servers without using public or private key. That's amazing to me. I love it. So here I can get into the server that I want to get into, and I don't have to have any headache to get into it. So you can see, so that's that. I love that. So this is what we've built in. But now I'm gonna show you the beautiful part of it. There is also the admin portal. The admin portal has a whole bunch of stuff in there, and we can see all kind of stuff. The process we go through. These are the 7 steps for our CI/CD deployment. There's so much stuff that has to be done here, and we also have an eye, a lookout for people who wants to use the product and so on and so forth as we move forward. But before we go, I want to show you what the Ghost does. Okay, whatever we built, we also defend and protect. So Ghost is a tool that kind of demonstrates our capability to do that. Like I said earlier on, any organization can protect themselves. You don't need to buy those expensive tools. They are not needed. And the tools that you build with the agents are very, very good because they are customized for your environment, because the attack surface for your environment is different. They are ever different. As you can see, last scan is at this time, and this has been running from April 4th, 2026. The system is okay. Prism score is great. We have over 1.7 million wire entries, 19,868 attacks, 806 IP band. As you can see, they keep coming. And what's interesting is what we can achieve. Organizations buy all these things I'm showing you. These are tools, different tools they have to buy: network flow analyzer, APT incident, TIC, block IP, trusted IP. These are whitelisted tools that they have to buy. Now they don't have to buy none of that. There's no need to buy all these things here. Okay, these are threat events that we see in the space. All right, so you can read up on them. You can put it little agents anywhere you want and read it off here and so on and so forth. Scan reports and inquiries. This is immune. Immune is the adjudicated human that works with humans in the loop to make this final judgment, to render the final judgment. And these are IPs that we got caught in the crossfire and so on and so forth. This is amazing. It's something that we need to look into. And the records I kept auditing is easier this way, and so on and so forth. So this is the Ghost, our official defender, penetration tester, hound, dog, attacker, you name it, it does it. Now this is our report. The report is stemming from Universal Identity Verification System. We build fingerprint for all our entities. The principle is what we consider enforceable human authority. That's the principle. So these are the profile for various individuals. Like if I put my ID here, you will see. If I put my email here, my fingerprint will show up. This is my fingerprint. This is one of it. So let me see if I can pull another one up. So this is OKT grain. This is the grain that we create with the authorship when we use our the battery of multi-factor authentication to infuse in as a cryptographic material within a payload. So that one, I didn't get what I'm looking for there, but this one works all right. Okay, this works all right. It's just a fingerprint, and you can see the entropy here. You can see at what point that we were able to get it, how many bits were there. So there's something called oscillation, there's something called saturation and convergence. This gets a little, I don't want to get anyone into the weeds at this time, but it gets interesting. And we've benchmarked the products over and over again. We've tried and tested many things about it. But I think I'll stop here so I don't confuse you anymore. Bottom line is Any organization can have governance in executable format and is enforceable with full audit trails and evidence readiness for any type of compliance they want. You can defend your environment. You don't allow any breach in because you're going to be acting as what lymphocyte within the immune system, a bodily immune system. And you're going to keep threat actors at arm's length, and you're going to respond to threats in real time. And at the same time, you're going to continuously keep tabs with the compliances, and you don't have to buy huge team members, but you always gotta have humans in the loop to interact with the agents. Basically, AI native immune system and governance, AINISG. That's our product. Thank you for paying attention and listening to what I have to say. Take care now. Bye bye.